Okay, it's recording now. So we see that there are different matrices. So any kind of two matrix can they be added? No. But a kind of two matrices can be added, can be subtracted. Multiplied, it is not necessary to have a same dimension. So n times 1 can be multiplied. A matrix with n times 1 means row and column can be multiplied with the matrix 1 by n. So here it will give us the n by n matrix when we multiply or divide. Same thing happens with the division, but mostly we don't divide the matrices. We can just divide the matrices to get the inverse, right? Inverse of a matrix. What is that inverse of a matrix? We just know, or we will just know it shortly. So remember that not every kind of, not every kind of matrices can be added, only the or subtracted only with the same dimension. Let's see the addition and subtraction of a matrix. So it's very simple. We should have same order, 3, 2, 1. I'm just taking a simple, you can also extend it. So it's 2 by 2 matrix. B should also be 2 by 2 matrix. If B is 3 and 9, it's like 2 rows and 1 column, it cannot be added, right? So A plus minus B is not possible here. So the order, so either it should be 1, then it can be added, or it should be square, which is 12 and 9. So that's also 2 by 2. Now this can be added, and this addition and subtraction is simple. I will just use plus minus B because it's the same thing. So what is the addition? Come on, 6, 2, 14, 9, 10, 9 to 11. So same position of a element of row 1 and row 2 will be added into the same positions. So remember, addition and subtraction is always in the same positions, okay? Just ask the other students in the class to join this session, because somehow last session was dropped because I wanted to record and it didn't work out. They kicked me out. So I started a new session. And similarly, when we talk about, so this is positive, when we we added, and when we subtract, what will we get? 3 minus 3 is 0, 2 minus 12 minus 10, 1 minus 9 minus 8, and minus 7. So this is when we subtract. So this is addition and subtraction. There are some properties, we will learn about that in a quick way. Now let's see about the multiplication. Simple rule, don't get confused. Look at here carefully. This is a matrix A. A11, A12, A21, A22, A31, A32. Remember the position of each element, each number within the matrix. The position is defined by rows and columns. This is matrix A. Now we have, this is 3 by 2 matrix, and we have B. Let's say B is B11, B12, B13, and here you can also go for B14, just to make an example. And because this should be 2, so the column here 2, so rows must be same, because rows gonna cancel out each other. 21, B22, B2, 3, and B2, 4. And this is 2 by 4 matrix. So the answer should be the matrix with 3 by 4. Means 3 rows and 4 columns. How are we going to do that? It's really simple, but don't get confused. I'm going to use the upper part so that you can see it clearly. So what is A times B? Have a good look on this. So here we use first row and first column. And how did we do that? Here we use A11 times B11 plus A12 times B21. Do you understand? So this is our basically A11 of AB matrix, right? And hence this one is 1, and then this will be another one. A11, so first row, first column. First row, second column will be here. First row, third column will be here. First row, fourth column will be here in addition. So here I can say A11, B12 plus A12, B22. So this is another element of A22 of this matrix. So do you understand? And similarly, we use A11, A12, B13 plus A12 and B14. And let's take three matrix, right? So, and then we do the same thing with second row, first column here, second row, second column here, second row, second here. Do you understand this? Now let's take a numerical example, and let's take a simple example of multiplication so that you understand. Let's have a 2 by 2 matrix. A is 2, 3, 4, 1. That's 2 by 2 matrix. And B is 4, 5. That's 1 by 2. So answer should be 2 by 2. So AB, first row, first column. So there should be column here, 6 and 7, because it's 2 by 2. So let's take this example. So 2 times 4 plus 3 times 6. And here 2 times 5 plus 7 times 4. 3. And then this one. 4 times 4 plus 1 times 6. 4 times 5 plus 1 times 7. So if I solve it, so 2, 8, 16, 16 plus 18, how much, whatever it is. 10 plus 21, 31. 4 times 4, 16, 16 plus 6, 22. 4 plus 20, 20 plus 7, 27. So this is the matrix AB. So that's how we multiply. Do you understand? Now, can I multiply this one? 1 row and 2 column? That's a question for you. With this 2 by 2 matrix, first row, first column. But here we can say 2 times 4, but for 3 times we don't have any number, right? So we cannot do that. But if we have this 5 here, can we do now? Yes, we can do now. So first row, first column. So 2 times 4 plus 3 times 5. Second row, first column. So 4 times 4 plus 1 times 5. 8 and 8, 5 to 15, 15, whatever. You can solve it, right? So remember, so it's like 2 rows and 1 column. So it gives us 2 rows and 1 column. So this should be equal. The column of A should be equal to the row of B. Do you understand this in multiplication? Take this rule. Yeah, good. If you know this rule, basic rule, then it doesn't matter. Even it's like a matrix is big. So don't get confused. Just solve it slowly and simply and don't get confused, because if you get confused, then you're going to properly write a wrong number. So let's say this is a matrix with 9 by 5. So can it be multiplied with the matrix with 7 by 5 or 7 by 7 or 7 by 8? No, because this is not equal. So it can be multiplied with the 5 by 8. And the answer should be 9 rows and 8 columns. Mostly you don't need to do that. The computer software does that if there is a big one, means huge matrices. Mostly we deal with 2 by 2 and 3 by 3. So remember multiplication, because you're going to use this a lot, especially in formulating different other matrices. Usually we don't divide matrix. We don't, right? But to get the inverse, we does that thing. So what is inverse? A inverse. What is the inverse of 2? 1 by 2, right? So similarly, because A inverse is in denominator, so it is obvious that it will be divided. But there is a certain formula. You know the identity matrix, right? Identity matrix, I on diagonal 1 1 1 and rest 0 0 0 0 0 0 0 0 0. So this is identity matrix. So how to calculate the inverse? So A inverse is possible. To get the A inverse, how do we know that we can take the inverse of this matrix or not? So A inverse is possible when this condition is satisfied. When we multiply A with A inverse, it gives us A inverse times A, and it gives us the identity matrix. So when any matrix, when we multiply with its inverse, it gives us identity matrix. That's the condition. For example, how to calculate? We will also talk about inverse later on as well in detail, but at the moment, just remember that if A is A, B, C, D, then A inverse 1 upon AD minus BC, and this will change the position. So D will go for A. How it changes the position, we will prove later on. But first, now understand that this is the rule for A inverse. But don't worry, I will prove it to you that how did we get this, because this is really important to understand the concept. And the signs, here the signs will be changed. So here the signs will be changed, here the position will be changed, and here we get this. This is determinant. We will talk about the determinant of matrix. What is that? And this is adjoint of matrix. So now solve it. So let's say, for example, A is 3 2 4 1. That's an example, right? So what is A inverse? First we calculate this adjoint. So a determinant. So 3, because this is AD. So 3 times 1, 3, minus 4, 2, 8. Right? And times, this will change the position. So 1 will go here, 3 will go here, and this will change the signs. Minus 2, minus 4. So 3 minus 8, minus 5. So A inverse will be minus 1 by 5. So I just take 1 by 5 inside. So 1 by 5 minus 2 by 5 minus 4 by 5, 3 by 5. So now I multiply minus sign inside. So it will give me minus 1 by 5, 2 by 5, 4 by 5, 3 by 5 minus. So you can solve this fraction and you will get the inverse. So that's the main theme of the inverse. That's the main formula. We will prove it later on, because we just have 20 minutes to do this, to finish this matrix things. Oh, so you understand the inverse. So this is inverse matrix. Now, let's say transpose matrix. As I told you, in transpose, for example, if you have a matrix, rows and columns, there's a matrix with rows, certain rows and columns. Let's say it's 5 by 8 matrix. Means 5 rows, 1, 2, 3, 4, 5, and 8 columns, 1, 2, 3, 4, 5, 6, 7. Right? So you know what is rows and what is column. So A is this. So what will be the A transpose? It will change. We will change column into rows and rows into column. How? Simple. Let's say A is 3, 2, 1, 4, 5, 6. So 2 rows by 3 columns. So what will be the A transpose? 3, 2, 1, 4, 5, 6. So it will be 3 by 2 matrix. So that's the transpose of a matrix. Change the rows into column or change the column into rows. Understand? Now there is another one, is the rank. How to calculate the rank of a matrix? Simple. Non-zero number is the rank. So what is the rank? The maximum number of linearly independent row or column. So when they are not dependent on each other. For example, this is A, B, C, D. A is this. So what is the rank here? Rank is 4, because all numbers are independent to each other. All numbers are independent, so they have no relation between each other. So that's why the rank of this matrix is 4. But let's say if A is A square, A cube, B. So what is the rank here? Rank here is 1, because only one number is independent. All these are dependent to each other, right? Because A and A square and A cube. So you tell me quickly. You tell me, I'm going to write a matrix. You tell me the rank. A, B, D, C, B. What is the rank of this matrix? Quickly, quickly. What is the matrix? What is the rank of this matrix? Can you see? Come on. Who's going to tell me? You cannot? Okay, tell me how many elements which are... No, not 3. Why 3? Look, these two numbers, they are related to each other, right? B is here and AB is here. So these two numbers are only independent. So there's no CD other than these numbers. So here the rank is 2. Yeah, so one told me 2, and he or she is right. So that's how we calculate the rank. So be careful. So it doesn't matter that it is like one-time relation, so we can count it. No. If there is any relation, we shouldn't count them. So just independent. You can take an example. Like if A is 6, 3, and 2, 8. So what's the rank? 0, because all the numbers are dependent on each other. So 6 and 3 are in. But if I say 7, So now what is the rank? 2, right? So if I say 5, what is the rank? 4. So that's how we calculate rank. So this is how we take the rank. Let's talk about the trace of a matrix. What is the trace of a matrix? I'm just telling you the basics. Later on, we also gonna talk more in details. So what is the trace of a matrix? Simple. It is the sum of all the numbers in diagonal. That is, if A is A, B, C, D, then what is the trace of A? Diagonal. First diagonal, leading diagonal. So there are 2 diagonals, right? So leading diagonal means from right to left, or first diagonal. That's this one, right? So when I say diagonal, it's meant to be a leading diagonal. So if what is identity matrix, if there is a 1 on leading matrix, then it's an identity matrix. So what is the trace of A? A plus D. Let's take example. Quickly tell me. 5, 7, 9, 2, 4, 3. What is the trace of A? What is the trace of A of this matrix? Quickly, please reply quickly if you know, because if you understand the concept, then it's really easy for you to know. Tell me. What is that? What is the trace of A of this matrix? Okay, someone told me. Let me see. No, there is no trace because there is not a proper diagonal. So you see, one number is bigger. So diagonal is always in a square matrix. So 4, 3, 2. Now there will be a trace, and the trace will be 5, 2, 7, 7, 2, 9. So trace of A is 9. So sometimes you need to grab the concept, okay? So if this is the matrix, you cannot take the diagonal, like, because there, where is the, like, because there's like 3 columns. So, but the rows are not 3. So you're gonna take the trace of a square matrix. So understand? So that's, you see, you need to understand the concept clearly. So that now it's a really important, another really important concept, and we have 10 minutes to do that. Hopefully we will do it. Shall we do that now? Okay, yeah, we can do that. It's easy. So if you understand all the concepts, so next concept is really important, right? What is this? This is eigenvalue. So there are certain concepts to understand eigenvalues. It's together. Eigenvalues of a matrix. It's not a big science. It's really easy. If you understand the previous ones, it's really going to be, what is eigenvalue? What is eigenvalue? Eigenvalue, whenever there is a long-term relationship between different variables. So I have X variable and it has different numbers. I have Y variables, it has different numbers, X1, X2, X3, and so on, Y1. So I put it in a matrix form, and we believe that there is a long-term relation. For example, economic growth and investment is a long-term relation, right? Not a short-term, not for 2 months or 3 months. So there's a long-term. Remember, any relationship is, if it's more than 1 year, then it's a long-term relationship. So between 2 variables, if there's a long-term relationship, we need to test this relationship. So for testing this relationship, that how significant this long-term relationship is, it is really necessary to find the eigenvalues. It's really easy. But first you need to understand that what is eigenvalue. Basically, it's a set of number associated with each linear, as I told you, y equal to x1 and x2, whatever, right? So this is the numbers. This is basically, so it's a linear equation, one linear equation, two linear equation, three linear equation. So number associated with it, that's eigenvalues. So eigenvalues is, you can say, is a set of a number. Numbers related with each linear equation in a system of equations. Understand? It is also known as the characteristics. Roots. So we need to calculate the values basically here. We can say that if A is a matrix n by n matrix, means 1 to n matrix. So here, let me, okay, I'm going to erase this one, okay? Well, if A is a matrix n by n, so whereas lambda, if an A is scalar, it's a two-dimensional or n-dimensional matrix, and it's with scalar number, so lambda will be the eigenvalue of A in such a way that there is a non-zero vector x. Let's say x is any vector. So Ax, this is a matrix X, is lambda x. This is the property to get the, because if we have this A, we have x, we have lambda, we have x, so it's really easy to calculate the value. Let's say x is a vector, x is a column vector, 2, 1, right? It's an eigenvector. How do we know that if it's an eigenvector or not? It's a column vector, but is it an eigenvector? How do we know? If A is a 2 by 2 matrix of 3, let's say 3, 2, 3, minus 2, 2, and lambda is given 4. So this condition should be satisfied. Let's see. So what is A? 3, 2, 3, minus 2, 2, 1, equal, lambda is 4, and x is 2, 1. So this is left-hand side should be equal to right-hand side in order to prove that it is an eigenvector and lambda is an eigenvalue corresponding to that vector. So if we solve it row into column, I'm directly using it. So I'm gonna skip the steps. So 3, 2, 6, 6 plus 2, 8, right? And because there is only one column, so 3 times 2, 6, 6 minus 8, 4, and equal 4 to 8, 4, 1, 4. So you see it's equal. So it means this is eigenvector. So any vector is an eigenvector if this is true. Understand? Note one thing here. If lambda is an eigenvalue of A, and x is eigenvector belonging to any non-zero multiple of x. So x can be any multiple of x. any, it can be more than. Then there will be more eigenvalues, and all of them are eigenvectors. So we can say, so if A is alpha x, then alpha, it should be equal to lambda ax. How? So we just take the constant out. So A and alpha ax times. So it's multiply, right? So can we write this? Alpha, and what is this? Lambda x. And because it's constant, so we can just put lambda here, alpha x. So this property holds true. So any multiple vector is. Now let's see in a more how to calculate the lambda, how to calculate the eigenvalue. So right now we just know how to calculate the eigenvector if the value is given. So if value is not given, how to calculate the value? Yeah. Okay. So let's say, usually, let's say A is any square matrix. Square matrix means n by n. Whereas C denotes any vector. There, just like there. So here C denotes any vector of one row and one of some rows and columns. Yeah, non-zero vector. Remember, it should be non-zero vector, because if it's zero vector, then it's no use. So it's just only one column or one row, or p row, two rows, can be two rows, can be any rows, n rows, three rows, four rows. So we just give a name, p rows, one column. So we know the condition, right? So here, what will be the condition? A times C should be equal to lambda C. That's the condition, right? So here A is a n by n matrix. N by n matrix. Here C is n by 1 matrix. So this will give us n by 1 matrix. So whatever the result is, it should be n by 1 matrix. And here we have lambda, and C is n by 1 matrix, right? So can I write that it gives us AC equal to lambda? So AC equal to lambda IC. I is a, remember, I is an identity matrix, the same order, n by 1. So C is n by 1. So we cancel out, and it will give us the multiplication. Now you know what is the identity matrix. So anything we multiply with the identity matrix, it will give us the same. So can I write this equation as in such a way? AC minus lambda IC equal to 0. I can write this, right? After this. Right? That's the condition. From here, you can easily get the lambda. Now, as this is non-zero vector, right? So to solve rho A minus lambda I must be a singular matrix. So whatever the matrix is, it should be a singular matrix. And now you must be wondering, what is this singular matrix, right? Let me tell you what is it. So do you understand this, right? So hold this, remember, or note this down, and because I'm gonna just continue from here. But first, let me tell you what is singular matrix. I think I forgot to tell you the singular matrix. So what is singular matrix? A singular matrix is a square matrix that doesn't have a matrix inverse. So it means if A is a singular matrix. If it doesn't, inverse doesn't exist, then A is a singular matrix. What is for that, we need that A inverse is equal to 1 upon A determinant and then adjoint of A. What is adjoint of A? What is determinant? To understand singular matrix, we need to know this one. So let's see the determinant. So let's say if A equal to A, B, C, D, E, F, G, H, I. All right. So what is the A determinant? So A determinant is like this one. So we need to solve this. This should give us one value. So let's take 2 by 2 matrix, not so big. Huh? A, B, D, E. So determinant will give us AE minus BD. So this value is a determinant. If there are more, then how to do that? Now we just tell you simple. A, B, C, D, E, F, G, H, I. So now 3 by 3. So if this is the case, first we use A, first row, first column. We use A, we put the EF, HI. Then minus. So remember, we use alternative sign. So first plus, then minus. And we use B. So B is second row, first row, second column. So we use this number within the matrix GI. Then again plus. So plus, minus, plus, and so on. And we use C and determines D, F, H, I. Now solve this inside. So it will give us A times EI minus FH and so on. And then we calculate one value, one single value. That's one single value is a determinant. We will see the example later on. For example, so this is 0. If a determinant is 0, then we say that it's a singular matrix. And because of it, we cannot get this one. Because if this is 0, so something upon 0 will give us undefined, right? So what is adjoint of A? So now you understand how to calculate determinant. Let's see how to calculate adjoint of A. For that, we need to know cofactors of A. So let's take example. So adjoint of A is a cofactor of A and transpose of that. Quickly, if A is 1, 2, 3, 4, 4, 2, 3, 4, right? So what is the cofactor? Cofactor position is really important. Remember, this position of I and J is really important. This is -1, and this is row and plus column. So cofactor of A in two cases, 2 by 2 matrix. So remember, these two changes the positions. So 4, but it changes, so it doesn't matter because they are same number. Or if it's like 5, then it will be 5, 4, and these two will change the sign. How and why changes the sign? Because of this. What is the position of this? This is first row and first column, right? So here we use -1 and 1 plus 1. It gives us -1 square equal 1. So that's why I put plus sign. Here it is 1, 2. 1 plus 2, and it gives us -1 cube. So it will give us minus. So that's why I put here two signs. So with the respective positions of a row and column, we use this formula to add the signs of a cofactor, only in a cofactor, okay? So this is like 2 by 2 matrix. And similarly, we can take 3 by 3 matrix cofactors. 1, 4, 8, 7, 2. So here, first we calculate A11, then we calculate A12, then we calculate A13, and so on. How? Simple. A11, what is A11? Because it's 1 and 1, so it will give us positive. So we don't need to use any sign. And take this one, so remove this one, so only consider this matrix and take the determinants. So 5, 2, 10, 10 minus 4, 7, 21. It gives us minus 11. So this is the position of A11. So when we write the cofactor matrix, this will give us 11, minus 11 should be here. And similarly, we calculate A12 is this position. So just remove this one and consider 3 and 4, 2. So 3, 2, 6, 6 minus 8, 4 is 32, and whatever the answer is. So this will be right here. And then this one, and then this A2, A3. So you understand? That's how we take cofactor. And after taking cofactor, just take the transpose of a cofactor. So values will be changed. So that's how we calculate. Now let's come back to the eigenvalues. So now you understand this is singular matrix. That's how we calculate inverse as well. So we know that A minus lambda I is identity value, should be 0, right? For example, let's say A is 5, 2, 1, 4. So we have equation, this one, we have equation, this equation, right? So what is the determinant? It's the determinant. So we can have A 5, 1, 2, 4 minus lambda 1, 0, 0, 1 equal to 0. So calculate. So can I write this as a lambda? And now minus 5 minus lambda 1, 2, 4 minus lambda. This is determinant is equal to 0. So 5 minus lambda times 4 minus lambda, right? Minus 2 equal to 0. Solve this and it will give us 4, 4, 5, 4, 20 minus 5 lambda minus 4 lambda plus lambda square minus 2 equal to 0. So it will give us lambda square minus 9 lambda plus 18 equal to 0. So now we have equation, so we can take lambda square minus 6 lambda minus 3 lambda plus 18, because if you add this one, it will give us 9 equals 0. So lambda will be common, lambda minus 6, and here minus 3 common, lambda minus 6 equal to 0. So lambda equal 6 and 3. So these are two eigenvalues. And once you have eigenvalues, you can also draw the eigenvectors. Just one more minute. And then we will just do in last 5 minutes, 5 to 10 minutes, I will just explain you the EViews. So one thing, so I will need your 5 extra minutes. We will compensate in the next lesson, maybe. Don't worry. So remember 3 things about eigenvalue. The sum of eigenvalue is the trace of the matrix. Second, the product of eigenvalue is the determinant. So remember last eigenvalue was 6 and 3. So what is the trace of that matrix? Sum of it. So trace must be 9. So you can prove at home. And product 9, 3, 6, 3, 3, 6, 18. So you can calculate the determinant, and it should be 18. And third one, the number of non-zero equivalents to the rank. So if in that matrix, if rank is non-zero value, eigenvalues. 6, 3, both are non-zero, so rank is 2 of that. So you can prove this through normal matrix. Okay, so next time we will use to implement the portfolio. So now I need your 10 minutes, so I will be really quick. I'm going to share the screen. So be there. Oh, sorry. So let's, you know what is matrix? Features of matrices, you know all these. So I'm going to give you the slides later on. All right, so we know all these things. We have done all these rules. So let's start the EViews. So I already have an EView example. So there are different data series. I know that you have another class. Just give me 5 minutes so that I can tell you. It's not a bit that difficult. So I will really thank you. So these are the files I have already made for you. And that's a time series data. Right, so I made like a separate file so that you can understand. That's panel data. That's time series data, right? And that's a cross-sectional data. So cross-sectional means different companies of a stock market. I think this is Shanghai stock market, and there are different values, right? Different values at the same day. That's cross-sectional data. Different companies. So the companies can be more, and the variables can be more, but it's only one time. Time series data, you see, it's a daily data and stock prices of one stock. So it's one company. And panel, you have different. For example, I have 5 countries, 5 South Asian countries: Pakistan, India, Bangladesh, Sri Lanka, Iran, and I have GDP growth there, their aid, their net export, their different variables data. Some data is missing, right? So EViews can tackle the missing data, and then here we have a number of years, right? Last 40 years. So let's start EViews. So this, you have the EViews, right? So you just double click, and it will give you the EViews 11, and the window is like this. So once you download it, maybe it will also give you this. So you just need to refresh it. As I told you, you just need to go to the request page, request them, and they will extend it for next month. Now this, either you can create a new work file, or open an existing, or open foreign. So I'm gonna tell you details. So first thing, if you have arranged these files just like I did here, so you just drag this and put it on the EViews. So EViews will ask you, you see, EViews automatically, it collected the data. So if you have data assembled in Excel, so you can just take it, drag it, and put it on EViews. So you have to check it. Each variable should be numeric or the label. So date is there, that's right. These are the variable, close, last, volume, open. So this is, remember, it automatically took it. So I will just reconfirm. Date, this and this, yeah, everything is this, and this is the name, description, date, we have all this. So I did this. It will again finalize it, by itself. So that's why I prefer EViews. I don't have to do anything. And I will just finish it. Link imported series alpha, yes. So now you see, it gave me the series and it's already there. What you have to do, you just need to process it. You see, if you go to view and you want to see the graph, you can see its graph. It's gonna be done soon. What kind of graph? Bar graph, line graph, spy graph, area graph. I just do the simple graph. So that's the simple graph, and I can see the trend of this stock over the last time 1 year. And similarly, we can also use descriptive analysis. We see the histogram and its shape. So that's a bi shape model, right? That's a bi distribution model. So it's like have a one symmetry, then another symmetry. So these are the things we can do. So remember, in view, there are all the names. So you have to check the unit root test. You will see what is unit root test. We have to do it with level and intercept later on. So if it gives us the probability, we will learn in next section, maybe after the holidays. Next 6th week, we will start doing the probabilities, and you know that what is this? What is this? Is like what is coefficient? What is standard error? What is t statistics, right? And what is R square? So we will all learn about all these things. What you can see here. So it's really important. So EViews just give you all these things in a single click, and then you can run. What you can do, you can also collect it together. So you just put control button, you do high, low, open, and then click the right and open as a group. Now you have a same, and then you want to see the process of a. You want to see the graph or tabulation or descriptive sample. Common sample, you get the mean, median, maximum, standard deviation, all these. So that's how you process. So now you just know. Take the file. I will show you one more file, and then I will leave you for next class. I don't want to save it. So now I take cross-sectional, drag it. Something happened. Oh yeah. Anyway, so you know the time series, right? So mostly you have to work with time series. There's some problem here. So now, oh, so you cannot see the shared screen. Oh, you can see, right? So that's what